Right now, as we speak, there are people dreaming of supercomputers who could instantly solve some of the biggest and baddest problems on the planet, developing miracle drugs, solving climate change issues, even the political ones maybe. And I'm not talking about AI, I'm talking about quantum computing. Last month, Microsoft unveiled what it called a breakthrough quantum computing chip that maybe could help us do all those things that people are dreaming of right now. And by the way, to make it, the company said it had created an entirely new state of matter. So you've got solid, you've got liquid, you've got gas, and you've got gold chip, I guess. I don't know. And this new tech could solve problems that current computers would take a long time to solve. Septillions of years, which is more than billions, more than trillions, and we're talking years. So that's a long time. Okay, so how close are we right now from actually seeing any of this in action? We have our friendly explainer, Nick Thompson, on. He's the CEO of The Atlantic and the former editor of Wired, and he's very busy, and yet he does this for us every now and then.
Yes.
Thank you very much.
Thank you, Nick.
How does this technology work?
Right, so the way most computers work is they take information and they transfer it into zeros and ones. The way a quantum computer works is it transfers information to what is called a quantum state, where it can be both a 0 or 1 or anything in between. So suddenly, you have the capacity to do much more information processing much, much, much faster, but it relies on very strange physics that are very hard to capture.
Including this material having to be very, very, very cold for it to work?
Yeah, so most quantum computers, most of the companies are pursuing a kind of quantum computing where you have to take your computers and you put them at almost zero in places that are earthquake-free, you know, these gigantic machines, because these particles in which these quantum effects happen are extremely unstable. And if there's any disturbance, well, then suddenly it doesn't work.
So if it does work,
Yeah.
I mean, some of the things that could be affected, roads that can fix themselves when they crack, miracle drugs, mapping and modeling of nature, no?
The roads aren't going to fix themselves. So these will be billion-dollar machines that are able to model processes that we cannot explain right now. My guess is that a lot of nature works on quantum effects, and so the first really interesting uses will be modeling biology, right? It will be scientific experiments that say, okay, how exactly do these protons work? What exactly is happening in the body? We don't totally understand it. How exactly can you sequester carbon? That is the best use case. The roads will not be fixing themselves, but we may have advances in drug development.
I love it. We're going to have wonder drugs and potholes at the same time.
That is the future.
You can never escape the
potholes
pothole. That's the one thing that is true. You said nature works on quantum. Like,
Yeah,
what does
so-
that mean?
So what we know, right, is very hard to capture quantum information. It's very hard to get quantum bits and to observe them and
I
to
don't even know what
create.
quantum itself means.
So quantum means, so think of a coin, right? A coin is normally heads or tails. Imagine a coin that is both heads and tails at the same time. It's very confusing. That is a quantum state. Yeah. Woo.
Mine was a little, okay.
Right? And so if you can get that and you can somehow get it in a structured environment, that is what a quantum computer is. Let me tell you about one other use, because it's really important. So what they will be able to do, and we do know this, is do math in ways that we cannot do it right now, which is great, except for one problem. The way that all information is encrypted, or most information is encrypted, is by using really fancy math that basically takes simple information, like a message, hello, it's Nick, turns it into a huge swath of numbers based on multiplying large prime numbers together, and then when it comes to you, math works in reverse, and you decrypt it and it says hello. With quantum computers, you may be able to take that huge swath of math, because they can factor prime numbers really quickly, and decrypt it. So that's the most worrying use of quantum computers.
And we're in a race to get this technology, different companies, different countries.
Yeah, I mean, well, whoever figures it out first, obviously, will have huge financial benefits. So Google, Microsoft, IBM are betting billions of dollars on it. There are quantum native startups. There's a whole swath of them that are working on it. And then, of course, United States government, Chinese government, like everybody would like it, and then there are probably some hackers who, you know, they don't have $1 billion to build a quantum computer, but as we get a little further along, they'll be like, this could be useful.
Yeah, everyone would like that coin that has tails on both sides.
Yeah.
I think the Patriots use
Tails
that
and
for their Super Bowls. Yeah. I am curious about whether we've passed the point where this is theoretical. Are we confident this is definitely going to make some sort of difference, or could it all just fizzle away?
I think it could all fizzle away.
Really?
Yeah, we do not know. So there are a bunch of pathways to this. So what Microsoft announced a couple weeks ago was topological quantum computing, which is a more stable effort. They're trying to find more stable qubits. Remember those little qubits that don't shake around or aren't perturbed as much? They're going a totally different path. They believe they've made progress. Scientists are skeptical. Others are trying to find other forms of qubits. We definitely have found some qubits,
Okay.
not enough to actually solve any useful problems. My guess is that 10 to 15 years, this is amazing.
Ooh.
But it's also possible it is nothing.
It sounds like it requires so much power to even get this to work. Is it realistic? And can it affect the lives of normal people?
Oh, it could absolutely affect the lives of normal people. And it requires,
Or could normal people use this technology?
normal people will not be using this technology for a long time because the machines are bananas and no one will have access to it. You may be able to license time on a machine, or your company may license time on a machine, but it's not like you're going to have a, remember, it can't be, you have to have it at absolute zero, so you don't want it at your laptop because then you'd have to sit in a freezer of absolute zero. It'd be really uncomfortable. So regular humans won't be using it for regular tasks. It will be for a long time in research labs and in really gigantic companies. But the benefits may accrue to all of us, even if we still have potholes.
Thank you so much. That was really great.
I literally just got smarter. Nick Thompson, thank you. You always
Thank
do
you.
that when you
That's
come.
great.